Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelyn Sindane. The lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. We are doing mathematics paper 2 revision, and we are going to focus on trigonometry, Euclidean geometry, and we should be able to write well. Remember, we did statistics as well as analytical geometry the first weeks of October, so it should be fresh. Remember to revise those as well on your own. Please, as advice, don't worry about paper 1. It's written, it's done. I know people will be sending you those memos. Please do not even open them. Just focus on the revision for paper 2 so that you can get better marks in paper 2. Don't worry about paper 1. Now, let's look at our topics for paper 2. We have statistics, which has between 17 and 23 marks. We have analytical geometry, which has between 37 and 43 marks. Trigonometry has between 47 and 53 marks. And Euclidean geometry has between 37 and 43 marks. Now, let's look at the target setting that we should give ourselves. Now, for us to get a 45% pass, we must get at least 68 marks for our paper 2. And statistics, we get a minimum of 12. But for us to get a bachelor pass, we should get a minimum of 15. Analytical geometry, minimum 18. For us to get a bachelor pass, we should get 25, a minimum of 25. Trigonometry, for us to get level 3, we should get 23 marks. But if we want a bachelor pass, we should get at least 35 marks. Euclidean geometry, we should get a minimum 15 or get a minimum 25 for a bachelor pass. Please set your targets nicely. We know what we want to get, but always aim for the sky. Do not aim for low marks, aim higher. That's all I'm saying. We have our information page. Please, let's refer to our formula page so that we do not write wrong formulas. Our quadratic formula there. We also have our distance formula, our statistics formula, answering questions. We also have, for trigonometry, we use mostly the formula in that slide, but it's there on our formula page. It's only a single page when you are opening your question paper. Moving forward, for trigonometry, we start from our cast diagram, where we define our trig ratios, sine, cos, and tan. I know we can use SOHCAHTOA, but let's also refer to the coordinate geometry so that we are able to get it in terms of X, Y, and R, and that's what we'll get. And then we have our cast diagram. In the first quadrant, we know that all our trig ratios are positive. In the second quadrant, only sine is positive because we know that in the first quadrant, our X and Y are positive. In the second quadrant, our X is negative and Y is positive. That is why only the sine ratio is positive. In the third quadrant, we have X and Y, and we know that both X and Y are negative in that quadrant. Hence, negative divided by negative will give us a positive. Hence, only tan is positive. In the fourth quadrant, our X is positive and our Y is negative. That is why only cos is positive there. And then we also look at our reduction rules, where we have in the first quadrant, either we are dealing with theta or 90 minus theta. And then in the second quadrant, we are dealing with 90 plus theta or 180 minus theta. And in the third quadrant, we are using 180 plus theta. And in the fourth quadrant, we are using 360 minus theta. I know that because here we have our 270 degrees. 360, 0, 90, 180. Some of us are comfortable using 270 minus theta and 270 plus theta, but I am not comfortable, therefore I will not discuss 270 minus and 270 plus. We move on now. We know that for 90 minus and 90 plus theta, we are dealing with cofunctions. Sine becomes cos and cos becomes sine. We must always remember that. Now, to just add on, I have illustrated those theta, 90 minus theta, 90 plus theta, and the signs of our reduced ratios there so that we are able to do and apply our reduction rules. I will also show the reduction rules now, where we have 90 minus theta. Sine 90 minus theta gives us cos theta, and cos 90 minus theta gives us sine theta. Sine 90 plus theta gives us cos theta, and cos 90 plus theta will give us negative sine. Because cos is negative in the second quadrant, that is why cos 90 minus theta is negative sine there. 180 minus, we remember this, but let's just to refresh our memory. I know we are going to be using them just now. We also deal with our negative angles. Sine negative theta will give us negative sine theta, and cos negative theta becomes positive, and tan negative theta, it's negative tan theta. Let's also remember this. We say it is 0 degrees, 90, 180, 270, 360. We are moving in an anti-clockwise direction, and when we move in the clockwise direction, we are dealing with negative angles. That's where we'll have our negative theta there. So 0, negative theta, then we will have 90, 180, and so on, if we are moving in the opposite direction. So now, when we are applying our reduction rules, we are saying whenever we get an angle which is greater than 360 degrees, we subtract 360 degrees so that we get an angle which is between 0 and 360 degrees. Then we are able to apply the reduction rules. If we are dealing with negative angles, we can add 360 degrees so that we are dealing with positive angles, and then we apply our reduction rules correctly. And then we have our identities that we did in grade 11. We know that cos squared theta plus sin squared theta is equal to 1. And we must be able to identify this one whenever we are solving problems. So it means wherever I see 1 minus sine squared theta, I can just put cos squared theta there because this is an identity. They are equal in value. Now, here is an activity that I will give you 4 minutes to look at. Welcome back. Remember, for our CAS diagram, the question can come in terms of a variable, or it can be given as, for example, you can be given 13 cos theta minus 5 is equal to 0. So remember, this one will require us to first of all rearrange so that we get our cos theta as equal to 5 over something. But this one, it's given in terms of a variable. So we are given that sine 36 degrees, it's square root 1 minus p squared. If you check, 36 degrees is in the first quadrant. So we'll draw our arm in the first quadrant. So here, the coordinates will be x and square root 1 minus p squared. Because we know that sine, it's y over r. In this case, our r is 1 because anything over 1, so we can write it as a fraction as square root 1 minus p squared over 1, so that we have the value of y and the value of r there. From there, we'll apply our theorem of Pythagoras to help us get the x value, and we should get our x value as p, and then we are able to determine tan 36 as our y over x. So that will give us the answer there. So remember, we get our tan 36 as that. It's 3 marks. Then we are supposed to find cos 108. Now, remember now, we can use our compound angle identities, we can use our double angle identities to help us solve this. So I will choose to use our reduction rules. Cos 108, it's more than 90 degrees, so we reduce it to an angle which is less than 90 degrees, and this will give us cos 108 as negative cos 72 degrees. But I realize that cos 72 degrees, I can write it in terms of 36 degrees. It becomes cos 2 times 36, it gives me 72 degrees. And 36 is what I'm working with. So from there on, I can use any of the identities for sine, for cos double angle, and this will give me negative 2 cos squared 36 degrees minus 1, and this will give us negative 2p squared plus 1. There are other versions of getting to the solution, but I think this one is easier. We get our reduction. We use our double angle identities. We choose the correct identity to use. We substitute and we get our 4 marks there. There are other versions. You can look at them if you are comfortable with other versions, but this one is straightforward. It saves us time. Now we move on to the second activity. We are supposed to solve without using a calculator into 1 trigonometric ratios. We are going to apply our reduction rules. I will give you 4 minutes to do the simplification there. Welcome back. I hope you were able to solve this one. Sine 140 degrees times sine 360 minus x over cos 50 times tan negative x. My advice would be always do your reductions using brackets. So this is the same as saying 180 minus 40 degrees, and it will give us our angle as sine 40 degrees times sine 360 minus x. This is the same as saying negative sine x over cos 50. We can do the reduction. It becomes this. We can for now leave it as cos 50, then that one gives us negative tan x. The moment you do this, you already have a mark here, and a mark there. You already have 3 marks. So let's quickly finish it up. So we know that cos 50 and sine 40 are the same using our cofunctions. So cos 50 is the same as sine 50. So either you choose to change sine 40 to become cos 50, or you change cos 50 to become sine 40. As it is done there, you'll get a mark for that. Remember, we have 1, 2, 3, 4. And then from there on, we change tan into that, and we should get our answer as positive cos, because we are having a negative divided by negative, it gives us a positive. So we get our answer as such. We move on to the next one. We are supposed to prove the identity. We are proving that the left-hand side is equal to the right-hand side. So the left-hand side looks more complicated. Remember, we are having negative 2 sine squared x plus cos x plus 1 over 1 minus cos 540 minus x. So let's deal with the left-hand side on its own. So we are able to see that. Remember, cos 540, we said we subtract 360 degrees, it will give us 180 minus x, and the reduction of it is negative cos x. Our numerator is in terms of sine and cos. So on our denominator, we are having cos. So it means somewhere up here, we must try and make sure that our identity is in terms of cos. So that will give us, where there is sine squared, we substitute with 1 minus cos squared, and this will give us our answer as negative 2 plus 2 cos squared x plus cos x plus 1 over 1 plus cos x. From there on, we simplify and we get 2 cos squared x plus cos x minus 1 over 1 plus cos x. From there, we factorize the numerator, and you will find their common terms, and we get this as 2 cos x minus 1, which is what we have on our right-hand side. So you get a mark there for substituting the identity, and then we also get a mark for factorizing, and then we get our final answer, simplification to get that one. We get our 4 marks. Moving forward, we need to discuss our compound and double angles that we did this year, and you will find we should be able to identify these and use this. So if we are having the expanded form, you should be able to reduce it. If you are having the compound angles, you should be able to expand, and then you simplify in order for you to get what is needed. Now, so if you check there, I have alpha and beta. I add them, I get alpha plus beta, or A plus B. We can use sine, we can use cos. We also have where we have alpha minus beta, which is this part here. This is alpha minus beta when you want to find that angle, because the whole angle is alpha, this one is beta. So to get alpha minus beta, it is this piece here of our angle that will give us alpha minus beta. So we should be able to get that one, and we are using this and that. And then we also have double angles. Alpha plus alpha will give us 2 alpha, of which we should be able to get our sine 2 alpha, which is 2 sine A cos A. And then we also have our cos 2 alpha, which is cos squared alpha minus sine squared alpha, or 1 minus 2 sine squared alpha, or we write it as such. So we should be able to identify these three for our cos double angle. We shouldn't forget. Moving forward, here is a question, but in the interest of time, I will just give you 5 minutes to answer both questions. Welcome back. Now we are given cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Remember, as a way of remembering these compound angle identities, cos, we know that it's cos cos, sin sin. Sin, it's sin cos, cos sin. So you should be able to see which one is going to help you get what you want. So you are supposed to use the given identity to derive the formula for cos alpha plus. Now, you cannot go to the formula page and then just copy. The formula for cos alpha plus must come at the end. You must show how it begins. So I have cos alpha plus. I know that I can write this as cos alpha minus negative beta. Negative and a negative gives me a positive. Then I have to substitute in what I'm given here in order. So where there is alpha, I'm going to substitute alpha. Where there is beta, I'm going to substitute with negative beta because I have to substitute here. And this will give me that, and I will get cos alpha cos negative beta plus sin alpha sin negative beta. Applying the reduction rules, the reduction of cos negative is positive cos, and the reduction of sin negative beta will give me negative sin, and negative and a positive will give me a negative, hence I'll get my sign as that. So I'll get a mark for that, a mark for substitution, a mark for applying the reduction rules, and then getting my answer at the end. I get my 3 marks there. We have to simplify completely. 2 cos 6x cos 4x minus cos 10x plus 2 sine squared x. Now, for now, I'll suggest do not tamper around with this 2 sine squared, because here also you are seeing I've got cos 6x cos 4x. So it means somehow that's where my lead is. I have sine 6x cos 4x, in which case I know that if I have 6 plus 4, this gives me 10. So it means somehow I have to break down this cos 10x into 4x and 6x. And this will happen if I do that, minus cos. I then use my compound angle identities to expand this and simplify, and it will give me that. And I'm able to see that 2 cos 6x cos 4x minus this, these are like terms, it will give me cos 6x cos 4x plus sin 6x sin 4x plus sin 2 sine squared x. From there on, I am able to see that this is cos alpha cos beta plus sin alpha sin beta. I'm able to see that I can write this as cos 6x minus 4x, which will give me cos 2x if I'm reversing the expanded form of my compound angle identity, that one. I can write this as cos 6x minus 4x, which will eventually give me this cos 2x. And I know that cos 2x is an identity, and I choose the identity of 1 minus 2 sine squared x, and negative 2 sine squared plus 2 sine squared will give me 0, and hence I'll get my answer as 1. So we should be careful when we are using this. Let's find a way of seeing which identity is going to help us simplify this. So that's that. So we get our 5 marks there for breaking that one down, expanding, simplifying, and then getting that one, substituting the identity and getting our answer as 1 there. We get our marks. Moving forward, we also have to solve trigonometric equations, and we know the type of equations that we have. But what's important is that we somehow get to this stage where we have sine x equals, or cos x equals, or tan x equals. Now, we have to emphasize that normally if we get a negative angle, remember we said sine it's negative in the third and fourth quadrant, it will mean our solution lies in the third and fourth quadrant. We find our reference angle and then we use our reduction rules, where we are saying our solution is in the third quadrant. Third quadrant it's 180 plus, and in the fourth quadrant it's 360 minus. And please do not forget to write the period for the sine function. Sine and cos, the period is 360 degrees, and for tan the period is 180 degrees. And then also we should remember that our k is an element of integers. We have to always write that one down, and then we get our marks there. The alternative for solving trigonometric equations, we use the graphical method, where we use the plus and minus between, and then we get our solution as such, and we are able to get our final solution. As you can see, the period for the sine function is k is 360 degrees, cos 360 degrees, and for tan it's 180 degrees. But we do not forget, because we can either move in the negative or positive direction, hence we are multiplying by the integers there to give us the solution. Now we are supposed to determine the general solution of tan x is equal to 2 sine 2x, where cos x is less than 0, meaning where cos is negative. So to solve this one, we are going to use the identity for tan. It's sine x over cos x, and sine 2x, we know that it's 2 sine x cos x. From there, we will have sine x is equal to 4 sine x cos squared x. We do not divide by a variable, so we can't divide by sine x. What we are going to do is we factorize so that we get sine x as equal to 0, or 4 cos squared x as equal to minus 1 as equal to 0 as well. And this will give us our two solutions as sine x is equal to 0, or cos squared x is equal to 1 over 4. Remember now, so it means cos x will be plus or minus the square root of 1 over 4, which will give us cos as negative 1 over 2, because we want where cos is negative, so hence we are only choosing cos x equal to negative half. We are not using cos x equal to positive half. And then from there on, we will use for sine x equals to 0, our solution becomes 180 plus k times 360, k element of integers, or when our cos x is negative half, we find our reference angle as 60 degrees, and our solution in the second quadrant becomes 120 plus k times 360, and in the third quadrant it becomes 180 plus our reference angle, which is 60 degrees, and that will give us 240 plus k times 360. We get our solution there. Moving forward, there is another alternative solution where we are saying we use, instead of cos squared x, we substitute with sine, and then we'll get 3 sine x minus 4 sine cubed x. Taking the common factor there, it will be sine x, and that will give us 3 minus 4 sine squared x, and then we will have sine x is equal to 0, or sine squared x is equal to 3 over 4, and sine is equal to plus or minus the square root of 3 over 4, which will give us sine as plus minus square root 3 over 2. So where cos is positive, we know that in the second quadrant, sine is positive and cos is negative. Hence, we take the positive square root of 3 over 2 there, and then we find our reference angle and we get our solution there. Now, moving on, We also look at our trigonometric graphs. Remember, amplitude, the vertical shifts, the period shifts, we looked at these earlier on, but just go through them so that you know what affects the period, what affects the amplitude, and you use it to answer questions as such. So the period of sine x, we know that is 360 degrees, and we also know that if we are given that it's sine 2x, we divide the period by the coefficient of x, which is 2, and the period will be 180. If we are given cos 3x, our period becomes 360 divided by 3, and we get 120. We also have our mixed shifts, where we have our amplitude changing as well as our k values changing there. Half x, we know that we'll divide 360 by half, and we get a period of 720 degrees. And we also have horizontal shifts. Sin x plus p, we know that our graph shifts to the right. If it's a plus, it shifts to the left, and if it's a negative, it shifts to the right. So if it's a plus p, it means it's p units to the left, and if it's a minus, we know that it shifts to the right. So if it's sine x plus 30 degrees, we know that the graph of sine shifts 30 degrees to the left. If it's sine x minus 30, is the graph of sine x shifted 30 degrees to the right, as an example there. And how does the amplitude or the value of A affect? We know that it flips the graph about the x-axis. You are able to see that if we have our A as positive, the graph of sine will look like that. If our A is negative, then whatever is positive on the graph of sine x becomes negative on the graph of y is equal to negative sine x. Our amplitude is A, our period is always divided by the k value that we are having there. Q affects the up and down movement of our graphs, and we move on. There is an illustration. If I have y is equal to 2 cos 3x plus 1, I'm able to find the graph of 2 cos 3x. The period is going to change to 120 degrees, and then plus 1, it means where we had a maximum 0 and 1, it shifts 1 unit up. Our minimum also shifts 1 unit up, and the new graph would look like this. This is the graph of y is equal to 2 cos 3x plus 1. So we are given the interval is a restricted domain, so we should also be able to get our interval for the range using what we are given there. So we should be able to do those translations of our maximum, minimum, so that we are able to determine the range as well. Moving forward, we are given those two graphs. In the diagram, we are having the graph of f of x is equal to tan x, and g of x is equal to 2 sine 2x. They are drawn for the interval that we are given, and we are told x is between negative 180 and 180. A has coordinates 60 degrees and k, and B are the 2 points of intersection of f and g. And then we are supposed to write down the period of g. If we look at the graph of g, it starts from negative 180 to 0. Then the cycle begins again. So we can say we form a complete cycle. So the period for g will be 180 degrees. And then we have to find the value of k. How do we find the value of k, which is the point of intersection with coordinates a? Our x value is 60, and we have to find the value of k. So to help us get that, I can either use f of 60 degrees becomes tan 60 degrees, then we are able to get that tan 60 degrees will be equal to root 3, and it will give us the coordinates there. So here are our solutions. So we get our k as square root 3 or 1,73. The coordinates of B, if you check B, it is also the point of intersection of F and G. So the coordinates of B will be negative 120 degrees and square root 3, because you can see that these are in the same point. That's our tan graph. That's our graph for 2 sine 2x there. And it will give us those coordinates. And then write down the range for 2g of x. Now, what is the range for g of x? We are able to get the range as between -2 and 2 because of this 2 as a coefficient. We know that this sine 2x, it has a maximum -1, a minimum -1 and a maximum 1, hence the range will be -2 and 2. Because we are multiplying this by 2, it will become -2, and we have that one as +4. We move forward. Now, for which values of x will g of x plus 5 minus f of x plus 5 degrees be less than or equal to 0 in the interval -90 to 0? Now, g of x plus 5 minus f of x plus 5. So we are saying, where do we have g of x plus 5 degrees being less or equal to f of x plus 5 degrees, less or equal to? We want to find that region. Where do the two intersect? So you will find they will intersect at that point, and that point will be around -65 degrees as well as -5 degrees there. We are shifting 5 degrees to the left. So it will be between -65 because they are intersecting at -60 and 0. So if you are shifting 5 degrees to the left, it has to be there. Now determine the value of p for which sine x cos x is equal to p will be exactly 2 real roots in the interval x element of -180 and 180, and that question is 3 marks. So you can see that our transformations are being applied here. So we are saying sine x cos x is equal to that. And now we are saying 4 sine x cos x will be equal to 4p. And then from there on, we are able to use our double angle identity. We can write this as 2 sine 2x. And this, remember, from our range, it's plus or minus 2 for our maximum and minimum. We said this will be equal to between -2 and +2. That's our maximum. So we equate it to 4p, and our minimum, we get that. And then from there, we get our p as -half or our p as 1/2. It's a high order question which requires us to understand the interpretation of our functions there and our identities. We move forward to trigonometry in 2D and 3D. Remember, we are solving questions where we are supposed to identify triangles. We redraw the triangle. It will either be a 2D or a 3D problem. We are applying our sine rule, cosine rule, area rule, and so on. So we always start with a triangle where we have most information. And then we do not forget about the trigonometric ratios. Remember, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan it's opposite over adjacent. So Don't forget that. I have highlighted it there. And then also, we have to revise our sine rule. If you want an angle, just make sure that sine of that angle is on the numerator and a is on the denominator. If you are looking for a side, the sides have to be on the numerator. It makes your life easy. Our cosine rule, we have it there, and our area rule, we have it there. But remember, these should be changed so that they refer to the diagram. If your diagram is in terms of PQR, it means your sine rule, your cosine rule should be using the letters PQ and R to avoid confusion. Now, when do we use the sine rule? We use the sine rule when we are given two sides and a non-included angle, when we are given more than one angle and a side, and also we use the cosine rule when we are given two sides and an included angle, or when we are given three sides. Area rule when we are given two sides and an included angle. We use the area rule. There is a question, but because of time, I'll ask you to look at this question later on. You will have to go through it so that we are able to also cover our Euclidean geometry. But I will allow you to just take a picture of that question. Otherwise, the reference, it's November 2021, question 8. You will do it later on and you practice such questions. I will move on to the next slide. There is the solution for 8.1. You are able to see it. The solution for 8.2 as well. You will be able to refer to the question and the memo for this question paper. We move on to question 8.3 and we get our solution as such. Now, the common mistakes that we make under trigonometry, we write amplitude as a negative. Remember, we said it is the magnitude. So it always has to be positive. Amplitude has to be positive, even if the value of A is negative, but amplitude has to be positive. We confuse amplitude and period. Amplitude, it's what it takes from our 0 to the maximum or to the minimum. That's our amplitude. Our period, it's what it takes to complete a full cycle, crest to crest or from arm to arm. So you must be able to get those. Period, we complete a cycle. Moving on, please, we shouldn't make assumptions. Remember, if it's not given that it's a right angled triangle, you can't assume it's right angled because it looks like. We also have to, when we do incorrect simplification, we reduce ratios using brackets to avoid signs mix-up. Working with more than one triangle for 2D and 3D problems, remember you always have to redraw triangles. The question says without using a calculator, you are evaluating an angle or you are getting an answer as 0.72. You have used a calculator, you lose marks there. Now, Euclidean geometry, we have our examinable theorems. The line drawn from the center of a circle perpendicular to a chord bisects the chord. Once you look at the diagram, you should be able to identify the theorem. The line drawn from center of a circle that bisects a chord is perpendicular to the chord. Remember, the diagrams for these will be different, so we know which one to use and the reason. Please refer to your examination guidelines for 2021 for the accepted reasons and the shorthand you can use. I know most of us are lazy to write. You'll find someone say opposite angles of CQ. It's not there in the examination guidelines. It has to be a cyclic quad. There is no CQ there. Now, Angle at center 2 times, you know the reason to use. Opposite angles of a cyclic quadrilateral are supplementary. We should know how to prove that theorem. We also have the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. That's our tan chord theorem. I know most of us do not know the wording. We just know that it's tan chord theorem. We must know the wording in our theorems because some questions require us to fill in the missing words. So we must know all the theorems word for word. We sing them as we do dishes, as we eat, so that we do not forget them. A line drawn parallel to one side of a triangle, these are the new ones we did in grade 12, divides the other two sides proportionally. That's our proportionality theorem. If two triangles are equiangular, then the triangles are similar. That's our similarity theorem. We must know the proof of these 7. And I'll encourage you, during the 10 minutes reading time, look for these theorems, and the moment you are told to start with proving those theorems. If there are 2 of them, remember, one could be 5, the other could be 7. You already have 12 marks guaranteed if you know the proofs. Then you can answer the other questions before you forget the proof of the theorem. And remember, whenever you are doing a proof, you must do a construction, or there must be a construction statement. Otherwise, the proof may be correct, but if there is no construction or construction statement, it's a 0. So let us be careful there. Do the construction or write down the construction statement. You answer the theorem proofs first before any other question. Remember, these are guaranteed marks. You do the proof right, you know that you are having those full marks. Now, there are the diagrams that are associated with our theorems, and you are able to see that you are given that OP is perpendicular to AB. You are required to prove that AP is equal to PB. There is no line there. So the construction you will make, you draw your radii OA and OB. Once you do this in your answer book, you know that you have got 1 mark. Even if you don't say construct, but you just show it on the diagram, you get your marks. On the second one as well, remember we are supposed to prove that this angle here is 90 degrees. So you do your construction, you have your 1 mark in an exam. So we move angle at center 2 times angle at the circumference. You know which constructions to make, and you should be able to get the theorems right. For this one, you form your triangles. We are using the exterior angle of a triangle to do the proof, and we move on. Opposite angles of a cyclic quad, we are supposed to prove that B plus D is equal to 180 degrees. So it means we are doing a construction of our radius O to C, O to A, and you can name this one O1, you can name this one O2, then you are able to prove the steps. Our tan chord theorem, the construction that you want to make, and this one uses, we know that the tangent is perpendicular to a chord, so I know that if I call this one 1 and 2, I also call this one 1 and 2. I know that E1 plus E2 will be equal to 90 degrees angle in a semicircle. Here B1 plus B2 is equal to 90 degrees. This, we know that a tangent is perpendicular to the radius, and then from there I use angles in the same segment because I'm able to see my bow tie there. So this angle here is equal to this angle here. B2 is equal to A2. Therefore, if B2 is equal to A2, it follows that B1 will also be equal to E1 there. And then you have proven the theorem. We move forward. Our Proportionality theorem, we know that we are dealing with our ratios. So this one, it's AP over PB. And also take note, you should be able to see the other ratios that can be asked there, and you prove it as such. We move on. Our similarity theorem, we know that if this angle is that one is that, this one is a plus, it means this will also be a hash, this one a dot, this one a plus. So you have to construct A, B, C, D, E, F, G, H, the construction that you make. You know that your AB must be equal to DG and your AC must be equal to DH. The moment you do that, you have 1 mark in an exam. So please, let's not leave diagrams clean. Let's do the construction and we attempt the proof as we move along. And remember, we answer the proofs first before we look at any other question. Moving forward, remember, all theorems and their converses that we learned in grade 11 should be known. Our corollaries also need to be known. Visualizing is important in Euclidean geometry. Geometry learned on lower grades is still applicable. That is the geometry of straight lines, triangles, quadrilaterals, the midpoint theorem, which is a special case of proportionality, the converse of proportionality and similarity, and the application of the Pythagoras theorem. We must make sure that we remember those. Now, just to remind you, if we are having parallel lines, we know that we can deal with our fan. We know that corresponding angles for F, our U, our co-interior angles, and then we have our N, which is our alternate angles. Others call it a Z. We know that those angles will be equal if the two lines are parallel. This one we call it a transversal line, and we should be able to see these whenever we are given a diagram. We have our alternate angles. We also have our corresponding angles. You are able to see as I listed them. We also have our co-interior angles that add up to 180 degrees. And then we have the types of triangles. Obtuse angle triangle, one of the angles must be more than 90 degrees. Acute angles, all angles should be less than 90 degrees. And we also have an isosceles triangle where we have a pair of opposite sides, adjacent sides that are equal in length, and we know that the opposite angles here will also be equal. And remember, we don't use base angles. We don't. We move on. Equilateral triangles, all sides are equal, all the angles are 60 degrees. A right-angled triangle, it's a special case of an scalene triangle where we are saying one of the angles is a right angle and it always obeys the theorem of Pythagoras. We know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles, and we also know that the sum of angles in a triangle add up to 180 degrees. We do not forget to recall that information. We've been doing it since grade 7, I think. We move on now and look at the cases for our congruency. For similarity, we know that if sides are in proportion, then the two triangles are similar. Or if we have two triangles that are equiangular, then the two triangles are similar as well. For congruency, we have angle side angle. We also have side, 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 if all the three sides are equal in length, but the orientation might not be exactly the same. Remember that. And then we also have a hypotenuse, right angle, and a side. So we have a right angle, a side, and the hypotenuse, also known as the RHS. We move on. Side angle side, where we have an side, an included angle, and another side. We can use that for our congruency. And then we have a special case, our midpoint theorem. If a line is drawn from the midpoint of one side of a triangle to the midpoint of the other side, then the line will be parallel to the third side and its length will be half the length of the third side, and that gives us our midpoint theorem. Now we have to answer questions now. Those are the questions that we have to quickly answer. So we'll answer them together as we move along. So we are saying, what will be the size of angle P? It's important to analyze the diagram. Always add the angles that you can easily see to be equal, isn't it? Now, if I check, MT is a tangent. So if it is a tangent, I know that this is my tangent code in the alternate segment, which means this angle here will be 66 degrees as well. If I also check, if this is 66 degrees, it means because I have parallel lines there, it means this one, and this PN becomes a transversal line, it means this will also be 66 degrees, because these are corresponding angles, because I'm having parallel lines. I can't use angle at center here because they are not subtended by the same code. That's a common mistake that we make. If I also check, PON is a diameter, which means this angle here is going to be 90 degrees. If this one is 90 degrees, I'm having triangle PMN, I'm able to get this angle here as 24 degrees, because sum of angles in a triangle add up to 180 degrees. From there on, I know that this is equal to that, which means N1 plus N2 should be equal to angle R, because this is OR is a radius, ON is also a radius, so they should be equal in size. Now I can go back and look at my questions. PON is a diameter of the circle centered O. TM is the tangent to the circle at M. A point on the circle R is another point on the circle such that OR is parallel to PM. NR and MN are drawn. Let M1 be 66 degrees. So that's what I used to get those other angles before I even look at the questions. So the first one, what is the size of P? So I'll say my P will be equal to 66 degrees. I have said the moment you are able to identify the size, already the reason is already there. You can't make a mistake. So this is tan chord theorem. Statement, reason. M2, already I've said PON is a diameter. That angle should be 90 degrees. So M2 is 90 degrees. This is an angle in a semicircle. 2 marks for Mahala. N1. So I've already found N1. I said N1 will be 24 degrees. These are sum of angles in a triangle. O2. O2 you can see O2 will also be 66 degrees. We said these are corresponding angles equal. Remember, whenever you are dealing with corresponding alternate angles, you must give your parallel lines because our MP is parallel to OR. You get full marks. If you do not mention your parallel lines, you will not get a mark for the reason. Let us be careful there. The next one, we are supposed to find N2. N2, remember I said our starting point is referring to triangle ORN. And we said R plus N1 is equal to 180 minus 66. We get 114. We divide that by 2 and we get our N1 plus N2 as 57 degrees. And then to get N2, we know that N1 plus N2 is 57 and N1 we have said is 24, and 57 minus 24 will give us our angle as 33 degrees there. So we get our marks. So we move forward. Here is a proof. JKLM is a cyclic quadrilateral and the circle has center O. Prove the theorem which states that J plus L is equal to 180 degrees. And we said we'll do our construction. We name our O1 and O2 and then we do the proof. We get our 5 marks. There is our proof. Moving forward, there is another proof. We have in the diagram O is the center of a circle, OD bisects AB. Prove the theorem that states that the line from the center of a circle that bisects a chord is perpendicular to the chord. Now, this is the one that was added after 2021. So you are able to see the construction that you make. You already have a mark the moment you do that. Please do not leave marks. And then from there, you use triangle ADO and triangle BDO. From there, OA is equal to OB. These are a D. OD is a common side. AD is equal to DB. It's given. So we are having congruent triangles, and the reason it's side, side, side. And then from there, we know that D1 is equal to D2 because these are congruent triangles. And using angles in a straight line, it's 180. So 180 divided by 2 will give us the 90 degrees. We have proven that OD is perpendicular to AB. Now, there is another interesting question. We are given that PQRS is a cyclic quadrilateral. PS is produced to W. TR and TS are tangents to the circle at R and S respectively. T is equal to 78 degrees. Q is equal to 93 degrees. We have to give a reason why ST is equal to TR. So, these are tangents from the same point or from a common point. Remember, ST and TR are tangents. So we know that tangents drawn from a same point are equal in length. And we know that our angles there will also, R2 will also be equal to S2 because we know that this is an isosceles triangle. So we know that these are angles opposite equal sides. We don't say isosceles triangle. So we want to find our S2 and S1 there. I've moved. Now, here is another interesting question. You will do it later on when you get home. We are given, it's from November 2021, question 10. In the diagram, BE and CD are diameters of a circle having M as the center. Chord AE is drawn to cut CD at F, and AE is perpendicular to CD. Let C be equal to X. Give a reason why AF is equal to FE. So, to give a reason, remember this is a line drawn from center, perpendicular to a chord. What does it do? It bisects the chord. So, this will be equal to that because this angle here is 90 degrees. So, line from center perpendicular to a chord, that becomes the reason. We have to determine, given reasons, the size of M1 in terms of X. M1 in terms of X, how do we do it? We are able to see that A1 becomes 90 minus X, sum of angles in a triangle. And if you check this arc, it subtends that angle A1. It also subtends that angle there. So we can use angle at center is 2 times angle at the circumference, like that. We get our 3 marks. Please, let's use the diagram effectively. Add information. This is 90 minus X. So this becomes 2 times that one. Using angle at center, 2 times angle at the circumference. We have to prove, giving reasons, that AD is a tangent to the circle. AD is a tangent to the circle passing through A, C, and F. That circle is not drawn, but we have to find a way of doing it. How do we do it? We have found that CAD is 90 degrees. A2 becomes, as our answer, A2 will be X, and we know that our A2 is equal to angle C, which is also equal to X. Therefore, it becomes the converse of tan chord theorem. We have to find the length of AE, given that CF is 6 units and AB is 24 units. So we are going to use our theorem of Pythagoras to help us get that one. So we get FM as 12 units. We also get EM as 18 units, and then from there on we use theorem of Pythagoras and we get AE as 12 root 5 units. Now you will also look at the November paper 2 2022 question 10. In the interest of time, I will ask you to do this one later on, and you should be able to follow there. It applies a lot of the grade 12 Euclidean geometry there. You will do it later on. You will do it later on. Now, as you can see, you can take a photo of the question so that you are able to look at it later on. We move on. We are given that S1, we have to prove, giving reasons, that S1 is equal to T2. S1 is equal to T2. You look at the questions there, and you should be able to answer them. So this is how I have proven it, but you are able to follow this on the memo later on. You also do 10.2, proving that the ratio AD over AR is equal to AS over AC. We have to prove similarity first, and then we prove. We have to prove that AC times SD, you use your similar triangles and then the proportionality theorem there, and then you show that they are the same. From the 2016 question, paper 2, question 10, that is the proof of our similarity theorem, but I like that part because it's asked piecewise. You should be able to follow the whole proof of that theorem, and you should be able to get your answer there. Now, in summary, we should always analyze the given information to identify what can be used. Always remember that diagrams are not drawn to scale. We do not measure. As candidates, we must use the given diagram effectively, add the information to the diagram, label correctly, and add answers as you move on so that you do not miss out. And then we draw all additional lines so that a clear picture of the question can be seen. One cannot use follow-up answers to answer previous questions. If you see that in 1.2, you have to show that the distance is 12, and then the first question, you use that 12 in the first question. It's not allowed. The properties of triangles and quadrilaterals, we must revise them thoroughly. And the use of color is encouraged so that you are able to visualize better, and we refrain from making assumptions. If it's not a given that it's a diameter, we can't assume. Good luck for paper 2 examination and all the best. I thank you for watching. Let's practice and practice, and the end is near, and all the best for paper 2.